Alrighty, so we are talking about NAVLOG basics, and my name is Morgan Bauer. I am currently in like southeast, or excuse me, southwest of Atlanta. Um, I'm a full-time flight instructor and CFII right now. And yeah, I volunteer for a bunch of different nonprofit organizations, especially with women in aviation. So just go ahead and get started. Alrighty, so just as a note, as far as this ground school, this is merely just the basics of the completing a NAVLOG. So always refer to your POH for your airplane and always gear towards your flight school and your training, things like that. Sorry, I'm going to set myself as the background here. All right. Alrighty, so sources used that I used for this presentation and that I use when I am teaching nav logs and that you will also need is the PHAK, the Pilot's Handbook of Aeronautical Knowledge, Chapter 16, and the VFR sectional chart. You'll also need your pilot's operating handbook for your airplane specifically and your E6B plotter. Along with that, of course, just weather. So whether that's aviation, weather brief, or whatever that may be, um, that you use your weather for flight. You'll need that, and then just some extra, paper for notes and things like that. Sorry, my technical difficulties are not working with me here. Okay, so this is just kind of what the basic Navlog looks like. Of course, depending on your flight school or where you download it from, it might change depending, but for the most part, this is going to be a standard average, layout of a Navlog. I know it's a little blurry there, but you're going to have usually notes, whether that's on the top or bottom, your aircraft in number. You're going to have all on the left-hand side your checkpoints or your fixes or your waypoints, some people call them. Um, then on the side of it, you'll have a VOR place to put the VOR ident and the frequency with it. You'll have your course. That's gonna be your true course. We'll talk about that in just a moment. Altitude, you're gonna have your winds for whenever you are planning this, your calibrated airspeed, your true airspeed, and then each of your courses. So true course, true heading, magnetic heading, and compass heading. You're going to have the distance and then ground speed, time off. That's going to be both for your times down there, your estimated time en route and your estimated time of arrival, depending on the time en route and the time that you leave, and then your fuel flow. You're also going to have columns for just to help you in flight for your airport frequencies and your airport and ATIS advisories. Again, this is just assuming you don't have any sort of like iPad or anything like that for those frequencies. So it's just all in one spot for you. Then on each of these, starting at true course and beyond, or excuse me, I'm sorry, starting at distance and beyond, you're going to have a box underneath that to write what is actually happening in flight. So, if your ground speed, if you predicted it based off of whatever you were calculating it to be, say 90 knots, but then it's actually 80 knots, well, then you're going to be able to use that to adjust your times, your estimated time en route and your gallons per hour, your fuel flow. So that's just kind of what a standard navlog looks like. Once again, things might be a little different, the ones that you've used, but overall, that's just kind of standard. All right, so just true course and finding points. So when you draw that line from point A to point B, you're measuring your true course. Just on your plotter from point A to, or excuse me, on your sectional chart with your plotter, you're measuring that line. That's your true course, just from point A to point B. Um, Once you do that line, you're going to note your total distance. So using your plotter, because it has the nautical miles on it. And then you're going to note each distance between each leg. So you can go ahead and skip that column, like if we were talking about, oops, from back here. So you can go ahead and skip to this column here. Um, Whenever you are marking, finding your points and noting your total distance, because you'll have the total here, and then mark each nautical mileage between each point as you're finding it on your plotter. So just a couple of tips for finding points. You want to use points that are off your wing rather than, right down the middle as you're flying because it's easier to see them when you're actually in flight than trying to go over something. So off your left or right. And then I also say if you're unfamiliar with a certain area, if you're staying kind of local or you've been in this area for a long time and oh, I know there's stacks right off the end of the runway. I'm sure that will be useful for our top of climb. Great. But if you're unfamiliar with the area, especially for like a check ride situation, if an examiner gave you, an example of somewhere that you've never been, I really recommend utilizing aerial view or Google Earth so that you can kind of see what's around there and what it'll actually look like when you're in the sky. So that sure, it may have it on the sectional of like a plant there, but what if it's not actually that visible? It's covered by trees or something. So it's just a good tip just to see what the aerial view would look like, um, so that you can actually see what it would look like when you're flying. So I also recommend writing L or R, so left or right, on the side of the point to know which side it will be on when you're actually flying. So when you put it on your fix here in this box, I just write a little L or a little R depending on which side of my wing it's on. Also next to your VOR section or in your VOR section, kind of whichever, I also write out the Morse code dots and dashes that is used for the identification of that VOR so that you're able to tune and ID it quickly. Because again, like yes, you can go pull out your sectional map in flight, that's 100%. But if you already have, the little dot dashes, you can just tune and ID it quickly. You don't even have to whip out the whole sectional in flight. Continuing on with true course and finding points. Once you have drawn your line and you found your points, like I said, you'll take your plotter and then you're going to identify which heading they're in. So remember, when we are flying this, we're not flying from point to point. We are still trying to keep that line as straight as possible, but we're just using those points and just having them off of our wings. I mean, preferably if you're in the left seat, obviously left seat's going to be very easy for you to just look outside and it's on your left. But of course, if there's a prominent landmark on your right, 100% go with it. Um, but yeah, we're not flying from point to point with that. So our heading, as much as possible, depending on airspace and things that you need to avoid, 100%. But for the most part, you want to try and keep that line as straight as possible. You don't want to be dotting around, zigzagging everywhere. Okay, so just a couple of definitions, just in general, and kind of how to remember them. Dead reckoning and pilotage, right? We talk about this a lot when it comes to navlogs. So, dead reckoning from the PHAC is navigation of an airplane solely by means of computations based on airspeed, course, heading, wind direction, speed, and ground speed in elapsed time. So, how I remember dead reckoning versus pilotage, because I used to get them confused a lot. Dead reckoning is I reckon we will be here at blank time. So you reckon, I reckon our heading will be X. I reckon our ground speed will be X. That's kind of how I remember dead reckoning. Pilotage, navigation by visual reference to landmarks. Pretty simple. It's the other one. It's the other definition. You're using your visual references outside as far as landmarks go and everything. So, all right, perfect. Next, we're going to move on to our altitude. So, whenever you're considering an altitude, some things to consider for altitude are your VFR cruising altitudes. So, remember 0 to 179, and these are magnetic, are an odd thousand plus 500, and a 180 magnetic heading to 359 or 359 degrees magnetic is an even thousand plus 500. That is from 91 159. federal regulation. You also want to remember take into consideration things like terrain and max elevation figure on your VFR sectional. So, if your max elevation figure is at 3,000, maybe 3,500 is just cutting it a little too close. So maybe let's go to 5,500. And then, of course, airspace, whether that's special use airspace or just general airspace. Of course, we don't want to be flying through any type of airspace that we're not allowed to be in or not allowed to, or don't have any clearance through, just willy-nilly. So always take into consideration airspace as well. Your winds and temperature. So I utilize winds and temperature aloft charts. I use aviationweather.gov for flights acceptable as well, but I'm a big proponent of aviationweather.gov. So remember to interpolate winds and temperature for climb and descent. So that meaning pick an altitude between the surface and your cruise altitude. So if your surface is at 500 and you're cruising at 3,500, I would say maybe pick, winds and temps aloft for maybe 1,000 or 1,500 or maybe even 2,000 or 2,500, but something kind of in between there because you don't necessarily want to be using the surface winds at your departure. Um, you want to be kind of in between there because, of course, when we take off and we're climbing, it's going to be in between that and our cruise altitude. So, really interpolate that. And that goes for your descent as well. So, whatever your destination airport is, find out what their AGL is, their field elevation, and then, of course, whatever you were cruising at, and interpolate between that so that you can kind of get a good distance in between because these navlogs are very hard to get precise. So the more we can do to be more precise, the better. So if that means kind of going in between those for your climb and descent, absolutely. I also do the same thing with my route. So if I'm going, from point A to point B, between two airports, and there happens to be maybe an airport right in between my route, I'm going to also use that for my winds and temps over that airport if it is reporting weather. So if my cruise altitude is, 5,500, there happens to be an airport right in the middle of my route or, you know, roughly in the middle of my route, I'm going to go and look at the winds and temps aloft near there as well, because then, again, we're trying to be as precise as possible. So as I go along my route, I'm looking at the different winds and temps aloft. That's another reason why I really like aviationweather.gov is because you can put in your route and then look at the winds and temps as you're going along the route. So it's really nice. All right, airspeed. A little memory aid for your airspeed is ICE-T. So that's ICT, indicated to calibrated to true. And you can go true to calibrated to indicated, but you can't, go indicated to true. So you can go ICT, and TCI, but you can't go I to T or T to I. You always got to get that calibrated before you find the outer ones. So indicated airspeed, that is just shown on the dial of your instrument. That is just what appears on the airspeed indicator. It has it's hasn't been corrected for instrument position and any other errors yet. It's just exactly how fast, what the instrument is reading. So you're going to utilize your indicated airspeed like by using your best rate of climb, so your VY. So in my airplane, my VY is 76. So I am going to utilize, I know that I will be climbing out at my best rate of VY of 76 knots to then convert it to my true airspeed. So of course I know I have to get calibrated, but that is where I'm utilizing that indicated. So I'm taking my indicated, I know I'm climbing out at a rate of 76 knots, so I can use that by saying, okay, I have this, so now I'm going to go find my calibrated to get my true. So, my calibrated airspeed, that is the speed at which the aircraft is moving through the air, found by correcting indicated airspeed for instrument and position errors. So, you can use this, or you can find this by using your E6B, just your whiz wheel. You can use that, electronic one or a manual, paper whiz wheel. And then last but not least, you have your true airspeed. That is your actual airspeed determined by applying a correction for pressure, altitude, and temperature to the calibrated airspeed. So you can find this in your POH. A lot of the times it will give you a true airspeed calculation because of with the pressure, altitude, and temperature. So I usually tell my students to use their POH because it'll give you also an RPM setting when you go to find this. You can also find it on your whiz wheel as well. All right. True heading, magnetic heading, and compass heading. So, true heading, that is the direction measured in degrees clockwise from true north, in which the nose of the airplane should point to remain on the desired course. So, this is found by calculating wind correction angle. So, we're just taking our line that we made, point A to point B, or, from fix to fix, whatever heading that was with our plotter, and then we are determining with our winds, okay, what, am I going to have to fly a couple degrees left or right depending on where the wind's pushing me? That's going to be our true heading. So our wind correction angle, that is going to be added to your true course if the wind is from the right and subtracted from your true course if the wind is from the left. So that's what you're putting in the one box. Let me go back here. So you find your points, whatever your course was, just from your line, from your line, from point A to point B. So say we were going, 090 heading east. Then, depending on whatever the winds were that day, that we wrote down and that we utilized with aviationweather.gov, I'm going to then go on the back of my whiz wheel here on the back where to find true heading and ground speed and get that wind correction angle. And so if it's coming from the right, it's a positive. If it's coming from the left, it is a negative. So um, that will also be able to tell if you're on your whiz wheel, on the back of your whiz wheel, if your dot, your final marking is on the more on the left, that's a left, that's a negative. And then if it's more on the right, then that's a positive. Okay. So that's your wind correction angle. So that's how you find true heading. You take true course, you add your wind correction angle, and now you have your true heading. Next, we have magnetic heading. So this is kind of a middle step in our conversion. So we are obtaining this by applying variation to true heading. So we already got our true heading by applying our wind correction angle. Now we're taking that true heading, so next new answer, and applying variation. So we're going to go look on our VFR sectional chart and we're going to find the nearest isogonic line and we're going to either add it or subtract it. So those isogonic magenta lines on the VFR sectional, you're going to see if it says, say, for example, +6 west, and my course went exactly through that, I'm going to add +6 degrees to my course. And last but not least, I have my compass heading. So that's the reading on the compass. We're going to find that by applying deviation to magnetic heading. So that is followed to remain on the desired course. Deviation is obtained from the deviation card on the aircraft. Now, some aircraft, they do not have to have a compass. So, for example, a G1000, they have 2 magnetometers, so they do not have to have a compass. So, that being said, there's no deviation because there's no compass to have deviation on, so they can skip this step. So, if your plane does not have a compass and is allowed to not have a compass, you can skip this step. So then you would just follow that magnetic heading. Your compass heading, though, and again, this is what we're just reading on the compass. So this is just for backup, if we lost our heading indicator or things like that, but this is the one that we're just following on our compass. If you have a 6-pack, then yeah, you'll follow this compass heading. But if you do have any type of glass and you still have a backup compass, you'll still follow the magnetic heading, but you're still calculating that compass heading in the case of emergencies and you lost, your glass and you don't have any type of backup and all you have to rely on is the compass. So in my little chart here, excuse me, my compass deviation card, sorry, it has for north steer 005. So the deviation is so great that we have to steer 5 degrees extra for north, so 5 degrees to the right. So if my course, from my magnetic heading, we calculated to be, say, exactly east, a 090. Well, we don't actually, for this example, we don't need to steer anything. It's correct. But say I had a, we'll go like a 130. Well, it's not listed on here, but it's closer to 120. So I'm going to come down here and do 2 degrees, add 2 degrees to that. So just as another example, say my course was a 310 that I've calculated. Well, it's not listed on here, but it's closest to 300. So I'm going to add 8 degrees to that. So you find whatever's closest here on your compass deviation card, and then you take what that is and then add or subtract it depending on whatever the compass deviation card is saying to do. Alrighty. Ground speed, estimated time en route, and our fuel burn, which is our gallons per hour. So our ground speed is obtained when using the back of the E6B, and it's noted during wind correction angle. So, like I said, when we were talking about the back of the whiz wheel and using getting our wind correction angle, it will also give you your ground speed at the same time. So you're just going to note that and then put it in your box here on your ground speed on your estimated box. And then of course we'll calculate our actual and when we get in flight, but you'll put it in that top line. Okay, so that's ground speed. And then you can obtain it by using the back of the E6B, or you can just do a quick math while we're in flight and do distance over time, distance divided by time. Estimated time en route is your total distance divided by your ground speed. This can also be obtained by using the front of the E6B. And then last but not least, your fuel burn. So first you're going to utilize your POH and you're going to determine how many gallons per hour are burned at a specific cruise configuration. So in my case, when we're at 65% power, I burn 10 gallons. So then I'm going to use my E6B to line up the gallons per hour under the arrow. And then I'm going to see how much time each leg is to find the specific fuel burn. So if my leg was like 6 miles, and then I would line up my 10 gallons per hour, and then I would get my fuel burn for that specific leg. Alrighty, and notes and tips. So use the notes section for literally anything and everything, is what I tell my students. So I would always put my pressure and density altitude formula, pressure altitude and density altitude formula. Just any sort of notes of where you got things, just note it, especially for any sort of examiner situation, so that immediately the moment they ask, where did you get this? And you freeze or whatever the case may be, you have it already ready, already written down for you. Like I said at the beginning, utilize aviationweather.gov and 1-800-WEATHERBRIEF.com or call a weather briefer always. And then write down your actual data in flight and utilize your E6B. You can use that in flight because I mean that's what they were made for. That's what they were built for, is to use them quickly in flight by pilots. Or you can use the quick formulas such as like distance divided by time to determine real-time data. So you can always get your ground speed off of, say, like your GPS, and then get your ETE off your GPS, and you can quickly calculate, your fuel burn, things like that. Alrighty. Let's see here. Alrighty, guys. Well, thank you so much. It was a pleasure, and I hope you all have a good night.